My name is Rama Abdelhadi, and I'm here presenting alongside my fellow teammates Kian Castro, William Lee, and Jason Chan. And today we are proposing our company Chromatic Solutions and what we as a company have to offer. Now, have you ever just been in a room with the worst lighting, the sun beaming at you, the glares on the screen, heat accumulating in the building, causing the AC to just not be a factor inside, as well as just making it hard to complete the task at hand? Now, what we offer is a full replacement of the traditional blind window system with smart glass, also known as smart windows, which is an eco-friendly, sustainable solution. This product will be highlighted throughout the presentation with proper research and the steps taken to support our claims, as well as explain the reasoning for replacing the traditional system.
Each month, National Ocean and Atmospheric Administration, which is NOAA, offer an outlook of the global annual temperature ranking at the year end. It is based in part on how wildly the global temperature have varying from month to month. According to NOAA analysis, last month also marked the 44th consecutive April and the 424 consecutive month, with temperature at least normally above the 20th century average. The 8 warmest April have all occurred since 2010. Climate change for the environment in the world will be raising sea levels, precipitation pattern change, vegetation becoming more dry, and caused by the greenhouse emissions. How can we protect the greenhouse emission? For that, we have the Greenhouse Gas Protocol, which is GHGP, recognized by the UK government, was developed by the World Business Council for Sustainable Development and the World Resource Institute. The GHGP helps define how companies manage and report the greenhouse gas emission, GHG. Crucially, the establishment of three categories of emissions, Scope 1, Scope 2, and Scope 3. In the article, we highlight two important notes. Natural gas and oil for electricity and heat in building accounts for 25% of the greenhouse. And second important note is significant amount of the US commercial building annual energy usage from two categories. 32% to heat ventilations and air conditioning, which is HVAC, and 25% is lighting. For those reasons, our solution is to change the people consumption, which is smart window. Recently, people raised their trust on the smart window since smart window environment friendly, cost effectiveness, and practicality.
As previously mentioned, global warming continues to negatively impact the environment around us. Recently, Silicon Valley and all across California there have been many wildfires that have ravaged the state. For example, the SCU lightning complex and the LNU lightning complex, which both happened back in August. The duration of the wildfire season has been getting longer due to a prolonged drought and an increase in drier vegetation, all of which is caused by climate change. Because of the wildfires, the air quality during these times reaches hazardous levels. Healthy, breathable air is usually colored green on the air quality index, while unhealthy, toxic air is shown in red or purple, as you can see in the image on the right. Everyone in the surrounding cities must limit their time spent outdoors, especially those with lung diseases, because the pollutants are harmful when breathed in. People may develop new lung diseases, or those already with them may worsen. With climate change being the main cause for these disastrous events, we ask you to consider implementing smart windows in your new facility to try and mitigate these effects. With smart windows, the operation time of the HVAC systems and the lighting fixtures around the building will see a significant decrease. Less electricity spent on these systems will lower your energy consumption and decrease the amount of carbon dioxide that will be emitted. Ultimately, this plan will help your company save money on the monthly electricity bill while also helping the environment by reducing carbon emissions. Firstly, our research teams will analyze the three main types of smart windows, which are electrochromic, thermochromic, and photochromic windows. We must understand how each window functions and what is the most optimal operating environment for them. Because of climate change, we will also cross-reference case studies performed in other parts of the world that have a similar weather pattern to the one we are projected to experience in the near future. So in this case, we focused on one from Madrid, Spain. The building specifications and calculations for energy consumption, return on investment, and many more will be based on the building America Center 2, which is located in North San Jose. And all of this data will be recorded on an evaluation sheet that our teams will collaborate on.
There are three types of windows. Electronic electrochromic smart window relies on electric source of energy such as voltage for functionality rather than a natural source of energy such as from solar energy from the sun. The tint of electrochromic glass is controlled by the amount of the voltage applied to the glass. Apply a lower voltage of electricity darkens that coating as lithium ions and electrons transfer from one electrochromic layer to another. Remove the voltage and reversing its polarity cause the ions and electron to return to their original layers, causing the glass the lining and returning to its clean state. So the second one is a thermochromic smart window. The thermochromic smart window simply use the heat from direct sunlight to tint the window when necessary. The more direct and intense the sunlight is on the glass, the darker it will become. This allows the windows to dramatically reduce the heat loading coming into the building, and because the glass transmission adapts continuously over the range of temperature, a natural balance and maximum use of the day lining is achieved. By design, the thermochromic windows help reduce the glue, fanning, and noise and increase the safety. We highlight it. And the last one, the third one, is photochromic smart window. The photochromic is a very common material that we are used, like eyewear is already made with the photochromic lens. The transitions from being line to dark when activated by line. The line must be intense enough and typically have enough ultraviolet radiation in order for the photochromic lens to react, and vice versa. When the line that activated the lens disappears or isn't intense enough, the lens will return to their clean and tainted state again.
In order to determine a baseline for the increase or reduction among all smart windows for numerous variables such as energy cost, energy consumption, and greenhouse gas emissions, external research articles must be considered. Luckily for us, researcher Thalberg and his group of scientists performed a simulation with the intent to determine the approximate amount of energy usage between these smart windows. This study focused on 3 distinctive climates across the world. However, we'll be taking a look at the Madrid, Spain simulation results, as that city's climate is relatively similar to our climate in the Bay Area. Overall, the big takeaway from the simulation is that the primary source of reducing annual energy consumption is through reducing the need to provide electricity for cooling, especially in the hotter months. This relationship can be seen in the figure on the right, where each factor of heat gain and loss is specified within the graphs. When looking at actual numbers, however, the electrochromic smart window requires 17% more power for the internal heat of a building to remain at a constant temperature, but we can clearly see that the electrochromic variant reduces up to 40% more energy consumption in the warmer months in comparison to the static window. Overall, we can see that across all 3 smart window variants, Thalberg and his group's simulations demonstrate that the electrochromic operative temperature variant smart window reduces up to 30% in annual energy consumption, with thermochromic smart windows reducing up to 15%, and photochromic smart windows actually requiring 1.16% more energy in comparison to the static window. When determining which smart window is best for the company, we must first dig deeper into the topic itself and discuss the optical parameters that should be best considered. Based on Thalberg and his group's simulations, it's important to choose a smart window that is most efficient in the summer months in order to reduce air conditioning and cooling loads. As a result, it's important to choose a smart window with a relatively low U value. This leads us to narrow our choices to the electrochromic and thermochromic smart window. If the U value is substantially high, such as for the photochromic smart window, the high rate of heat transfer across the window itself will make the cooling more inefficient, which results in greater power consumption. While both the thermochromic and electrochromic smart windows possess relatively similar SGHC values, the electrochromic variant possesses a larger SGHC value in a clear state and a lower SGHC value in its darkened state in comparison to its counterpart. As a result, the electrochromic window can be more flexible and adaptable than the thermochromic window, allowing the heating system of the building to be more effective. Overall, the thermochromic and electrochromic smart windows possess similar optical characteristics. However, the electrochromic variant is most effective to a certain degree in reducing overall energy consumption due to its dynamic control input. The model for the company building is based on the America Center 2 commercial building based in San Jose, in which the total acreage of the building is about 460,000 feet squared. According to the U.S. Energy Information Administration, the monthly energy consumption for a commercial building is approximately 16 kilowatt hours per foot squared. And since we're assuming that Silicon Valley Power is modeled to be the primary electricity utility company providing electrical energy to this building, the average cost of electricity for a commercial building is approximately 14 cents per kilowatt hour. Figure 18 and 19 illustrate and compare the energy consumption and electricity cost, respectively, between each smart window variant and regular static windows. Thus, the potential monthly savings is calculated as the net difference in the electricity cost between a control window and respective smart window. As a result, the monthly savings in electricity are added within the current investment return. Overall, the energy consumption for the regular windows are spread accordingly throughout each month and proportionally based on intuitive and arbitrary trends of power usage. The estimated amount of the consumed electricity and energy costs for each smart window variant is of course proportional to the results from the previous section with the Madrid, Spain energy simulations. When it comes to determining which smart window the company should invest in, there are two deciding primary factors that Samsung Group must consider: risk and return on investment. While assuming that the monthly revenue of Samsung Group is constant across all smart windows, the amount of money that is saved from energy consumption per month will pay itself toward the net return on the investment for that specific month. Investing in the electrochromic window is considered to be a higher risk for the company due to the substantially large initial cost and a greater time to be breaking even. However, the overall amount of potential savings in energy consumption in the long term is significant. As a result of significant cost reduction toward electricity, the amount of saved funding can be utilized for other sectors of infrastructure within the company. In contrast, investing in a thermochromic window can be considered to be relatively low risk for the investor due to the significantly smaller initial cost and a lower time that is needed to break even. However, the business will not be generating the greatest amount of potential savings in the long term relative to the electrochromic window. Samsung Group is on par with developed technological companies such as Google and Microsoft. As a result, they possess a large amount of funding and are willing to invest in a more expensive product. If the product is much more cost-effective in the long term in comparison to other related devices, Samsung Group will also be more willing to invest in a product that requires higher upfront cost. Overall, the electrochromic window variant based on operative temperature is the type of smart window that we are proposing in order to provide the company with greater reductions in energy consumption and costs, as well as to maximize overall cost savings.
Upon acceptance of this proposal, the first step will be to send out a team to evaluate your proposed building design. Window installation is usually one of the last things to take place when constructing a new building. Depending on how many workers we will be able to afford based on your initial investment, we will set up as many workstations to lower the amount of time spent on the project. The window installation team will begin on a different side of the floor depending on where other workers are stationed. This is to prevent any interference between the different workers working on the building. They will take the quickest path through each floor to minimize time spent on moving the workstations, and we will have quality inspectors periodically come and inspect installations to see if the windows have been properly implemented and that they will function correctly. The teams required to complete this project include 2 research teams, 1 planning team, and the workers responsible for replacing the windows. The research division will consist of 2 subteams with 4 members per team. According to the National Academy of Sciences of the United States of America, 4 members for a research team is the optimal amount for the best group cohesion. The first subteam will have 2 mechanical engineers and 2 electrical engineers. They will be tasked with researching how each smart window works and the process of replacing windows. The second subteam will consist of 4 environmentalists, all of whom will analyze local weather patterns in various places similar to the climate in Silicon Valley. The planning team will have lead engineers from research groups and budget managers who will compile all the data that has been gathered into an organized sheet. The team of workers will be determined when the budget managers figure out how much money is left. So these team qualities shown in the circle diagram are the ones various sources deem to be the most important for a well-functioning team. Some other qualities are listed to the right, including familiarity and good communication. Without these qualities, it will be hard to gauge how well each team member works together and what their work ethic will be like. Uncertainty between each member will only hinder the project.
The budget consists of construction costs, workers' pay, insurance, as well as drafting and any other equipment fees that may come with it. Starting off, we're working with the construction costs, and the main focus is building permits, which we have found varies depending on the size of the area you're working on, as well as the traffic of the area. The small cities, we found an average between $100 to $2,100, and big cities, an average between $7,500 and $10,000. The next thing we cover in the budget is the insurance, which not only covers workers' insurance, which is basically anything that could happen on the job is covered, as well as unused equipment. So equipment that's not being used during the construction phase that we don't end up using could be reimbursed. And this is an average between $1,000 to $5,000, depending on the resources used, as well as the construction size. Continuing on with the budget, we need to optimize the layout for the windows. So we need to pay for drafters and designers. This is typically about $50 to $150 an hour. We expect about 72 hours of work done for this layout. And average drafting costs could go between $2,000 to $10,800, solely depending on the previous experience of the drafter, the delivery time, and the design safety requirements met. Continuing on with the budget, equipment and material. So we do require a boom and scissor lift for operators to be able to go up to the higher spots and be able to work there and install windows. So we average about 2 to 3 weeks for window installation, and this average cost can be $1,000 to $1,500, with the max cost about $4,500. However, we do need a certified operator to operate these boom and scissor lifts, so that would be about $16.45 an hour, which is accounted for in the budget. Continuing on with the equipment and material, we do require a crane to bring our windows and other necessary material up. This could be about $1,500 per month, and with no actual expected date, because we could be using this crane on and off. It could take longer than a month, less than a month, so that is unknown. However, you do need to pay as well another operator that is certified to work on a crane, which is about $36 an hour. Now, a main part of the budget is the window cost, which is one of the things highlighted throughout the whole presentation. So electrochromic we know is $100 per square feet, thermochromic is $30 per square feet, and photochromic is $13 per square feet. This is varying on a basic budget that the company starts off with, and from there we will figure out the optimized window solution. Now, the last part of the budget that we do take into account is the cleanup. This is something that needs to be determined, as there's unprecedented uncertainties that we can't really take into account. And that's like unused materials, hazardous materials that needs to be recycled correctly, and any other recycling, basically. To wrap up this presentation, I would like to highlight the benefits of the smart windows, in which we've covered throughout this whole presentation, as we've shown and proven that it slows global warming, and as well as an eco-friendly solution that can save money not only in the electricity bill, but overall investment into a building. The final proposed smart window that we've decided to go with based off of our research is the electrochromic window, which generates the most profit in long term. However, it does cost the most, but it does have a return on investment turned to profit actually in roughly 2.5 years. And this is why we've chosen electrochromic to be our main source and product to be pushed out. This concludes our presentation. Thank you.